Hello friends, in today's lesson we are going to be looking at division and multiplicative inverse of modular arithmetic. Don't forget we are still working on basic operations under modular arithmetic. In our previous set of lessons we looked extensively at addition and subtraction operation, and in our previous lesson we looked at multiplication operation. So in today's lesson we are going to be looking at division and multiplicative inverse. Now, if you have not seen the previous lessons, you will find it quite challenging to understand those very lessons. So I advise to go and see the other lessons. So we're going to be starting with multiplicative inverse. So when we talk about multiplicative inverse, what does it mean? The same way we have additive inverse is the same way we have a multiplicative inverse. So when we talk about multiplicative inverse, we're talking about, okay, let's say 9. So don't forget that 9 is 9 over 1. So when we talk about multiplicative inverse of 9 over 1, it simply means what we're going to use to multiply 9 over 1 that will give us 1. So 9 over 1, what is the inverse of 9 over 1? For us to get the inverse of 9 over 1, it means the denominator becomes the numerator and the numerator becomes the denominators. That will be times 1 over 9. So the multiplicative inverse of 9 is 1 over 9, unlike additive inverse. For additive inverse, the additive inverse of plus 2 is minus 2. For additive inverse, we're talking about what we're going to add to a given number to give us 0. But for multiplicative inverse, we're talking about what we're going to use to multiply a given number to give us, to give us 1. So that does it. So the multiplicative inverse of A is 1 over A, to give us 1. The multiplicative inverse of s over y is y over x, which will give us 1 also. So yeah, just a few examples. So quickly, we're going to be looking at the first worked example. So we talk about the multiplicative inverse. What is going to be the inverse of 7 in modulo 9? What is going to be the inverse of 7 in modulo 9? So for us to get the inverse of 7 in modulo 9, now don't forget, whatever they ask us to get the inverse of has to be in a given modulo. So inverse of 7 in modulo 9, it could also be inverse of 7 in modulo 4. It could be inverse of 7 in any other modulo. But this is inverse of 7 in modulo 9. So what does this mean? It means what are we going to multiply with 7 that will give us 1. So inverse of 7, don't forget this 7 over 1. So the inverse of 7 has to be 1 over 7. We're going to swap the positions of the numerator and the denominator. So 7 times 1 over 7 will give us 1 in modulo 9. That's all we have. So if 7 times 1 over 7 gives us 1 in modulo 9, so you can say the inverse of 7 then has to be something we're going to multiply with 7 that will give us 1 in modulo 9. So it could be modulo anything, it could be modulo 9, modulo 8, modulo 10, or whatever. So 7 times something has to give us 1. So that very thing you're thinking about, has to look like 1 over 7. That's multiply 7 to give us 1. So this p we're talking about, for example, the p is going to represent the 1 over 7, which is the inverse of 7. So what is that? What's going to be that very number that will multiply 7 that will give us 1 in modulo 9? That's what we're going to do. Now it's very simple. You could approach this in various ways. So let's see. This is going to be 7p equals to 1 modulo 9. So don't forget, this very one here simply means remainder 1. That's what it means. So it means 7p was divided by 9, and we got something remainder 1. Whenever you see 1 here, whatever you see here, modulo something, simply means this very stuff is a residue, it's a remnant. So 7p was divided by 9, so that's going to be 7p divided by 9 equals to, let's say we're going to get q remainder 1 over 9. This is the divisor. So when 9 divides 7p, we got q, for example, I'm just assuming, we got q remainder 1, which is this one written here, over 9. So what's that going to be? That will be 7p over 9 equals to 9 times q is 9q plus 1 over 9. They are the same denominators, so this goes out, these two go out, so you're going to be left with this very stuff on top because of the equality sign. So that's going to be 7p equal to 9q plus 1. So you're going to assume, because we're looking for what p would be, what is that very number that will multiply 7 that will give us 1 modulo 9. So we're going to be we're looking for p. So if q provided, let's say q is 0, for example. So if q is 0, what's going to be p then? That will be 7p equals to 9 times 0 plus 1, that will be 7p. 9 times 0 is 0, 0 plus 1 is 1. Divide both side by 7. So p is 1 over 7. So EP is 1 over 7. So 7 times 1 over 7 is equals to 1. So 7 and 1 is 0, remember 1. So P could be 1 over 7. This is one of the major results that P could be. So let's see if Q is 1, what's going to be P then. So that will be 7P equals to 9 times Q, which is 9 plus 1. 7P equals to 9 plus 1 is 10. Divide both sides by 7. So P is 10 over 7. So it means P also could be 10 over 7. So 7 times 10 over 7, when we divide, you end up having 10. So 9 and 10 will give us 1 remainder 1. So 1 modulo 9. So let's try another figure out. Let's try another result. Don't forget that this Q you're talking about here is the answer. But the answer is not going to be focused on just the remainder we're looking at. So Q is 0. We don't know that Q is 1. So let's see if Q is 2. If Q is 2, what's it going to be then? Don't forget that that's what we're operating on now. 7P equals to 9Q plus 1. So if Q is 2, that will be 7P equals to 9 times 2, which is 18 plus 1. So 7P equals to 9 times 2, 18 plus 1. 7P will give us 19. Divide both sides by 7. It means P is 19 over 7. So AP is 19 over 7. So that will be 7 times 19 over 7. Times and you get your 19. 9 and 19 will give us 2 remainder 1. So don't forget that it means P can be 1 over 7 and P can be 10 over 7. P can be 19 over 7. It means either of these could be the multiplicative inverse of 7. Don't forget, the multiplicative inverse of 7 could be 1 over 7 itself, could also be 10 over 7, could be 19 over 7. So let's try Q equal to 3. Let's see if you're going to get a whole result. So Q equals to 3. Let's see what we're going to get. Don't forget the 7P equal to 9Q plus 1. So if Q is 3, what's going to be P then? So 7P equals to 9 times 3, 27 plus 1. So 7P equals to 9 times 3, 27 plus 1 is 28. Divide both sides by 7. So P is 4. This is a whole result. So don't forget all this result, they are all correct. P could be 1 over 7. So 1 over 7 could be the multiplicative inverse of 7. 10 over 7 could be the multiplicative inverse of 7 in modulo 9. 19 over 7 could be the multiplicative inverse of 7. Y 4 also could be the multiplicative inverse of 7. If you keep attempting different final results, different quotients, if you attempt 4, if you attempt 5, you may get other results. But the fact is this: whatever value P would be should not be up to the modulo 9 we are talking about. That's just a fact. So P should not be anything up to 9 or more than 9. So we're going to go with this. So it means the multiplicative inverse of 7 is going to be 4 modulo 9. Don't forget, it's very simple. So 7 times 4 is 28. So if 7 times 4 is 28, so what does it mean? 9 in 28, we're talking about 3 remainder 1. So the inverse of 7 in modulo 9 is 4 modulo 9, as simple as ABC. That's the inverse of 7 in modulo 9. So we're going to be looking at another worked example. Okay, guys, let's look at the second worked example. We are asked to get the inverse of 4 in modulo 5. Now, don't forget, when we talk about the inverse of 4, we're talking about a number we're going to use to multiply 4 that will give us 1. So what number is it? Don't forget, whatever we're going to use to multiply 4 that will give us 1 has to be something that will divide 4 itself. So that's, there's no other number than 1 over 4. So 4 times 1 over 4, don't forget that 4 over 1 is 1 over 4. So 4 times 1 over 4 will give us 1 modulo 5. So let's assume that this very 1 over 4 is Q. 4 times Q is 1 modulo 5. So that means we have the 4Q is equal to 1 modulo 5. So now don't forget, you have the 4Q equals to 1 modulo 5. So the Q represents something like this, 1 over 4, a number that will multiply 4 to give us 1. So the inverse of 4, the multiplicative inverse of 4, which is 1 over 4. So let's see that very number that will play the role of this 1 over 4. That number that will multiply 4, that by the time we convert to modulo 5, we end up having 1 modulo 5. So from the very first worked example, we said 4Q equal to 1 has to be 4Q over 5. When 5 divides 4Q is going to give us, let's say, X This is remainder 1 over 5. But we don't want to go this long route. So we're just going to assume since we have a positive result, we're dealing with positive 1. So we're going to create a multiplication table, a 5 times multiplication table. So we've just create it up like that, up the positive axis. So as we create it, whatever answer we get, we're going to add it to this remainder and then relate it, with this very number we have on the left-hand side. So let's see, 5 times 0 is 0, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, like, and so on and so forth. 5 times 5 is 25, 5 times 6 is 30. So we're going to use each of these results. Each of these results, you're going to add them to this. You're still going to get the same result. More or less like saying 5 times x plus 1. So that's going to be 4q equal to 5x plus 1. So we start assuming different values for x. So instead of going through this, so we just use a direct approach. These are the multiples of 5. So each of the multiples, you're going to add it to this very one that we have here. So once we do that, we equate it to the 4q here. So let's start with 0. First one is 0. 0 plus 1 is 1. So we say 4q equals to 1. The Bible starts by 4. It means q is 1 over 4. So the number that will multiply 4 to give us this 1 modulo 5, as can also, could be 1 over 4. So 4 times 1 over 4 is 1. 5, you write 1 modulo 5 is just 1 modulo 5. So let's check the next, which is 5. 5 plus 1 is 6. So if you say 4q equals to 6, the Bible starts by 4. So that will give us q 2 here, 3, 2 here, 2. So the number could be 3 over 2. 3 over 2 is 1.5. So 4 times 3 over 2 will give us 6. So we write 6 in modulo 5. That will give us 1 modulo 1, which is 1 modulo 5. So this could also be the result. We're looking for a whole result, a whole number. So if you use 10, 10 plus 1 is 11. So it means 4q equals to 11. The Bible starts by 4. So the q is 11 over 4, which is 2 remainder 3 over 4. So 4 times 11 over 4 will give us 11. 5 and 11 is 2 remainder 1. So this 1 would be 5. So this also could be the result. Don't forget, whatever is going to be should not be up to the modulo we're talking about. That's the lesser than it. Lesser than it. That's highest, that's the 4. Nothing more than or up to 5. So let's test the next, which is 15. So if that is 15, 15 plus 1 is 16. Let's see, it's going to give us a perfect stuff. So 4 equal to 16. So the Bible side reads 4. So the q is equals to 4. Wow, this is wonderful. So it means 4 times 4 will give us 16. So if 4 times 4 is 16, so 5 to 16 is 3 remainder 1. So as simple as that. It means what we're going to multiply with 4, that will give us 1 modulo 5. That is that very number that will play the role of the multiplicative inverse of 4. That number has to be 4 modulo 5. So our final result is 4 modulo 5. This is what we're looking for. So don't forget, others also could be the result. Even when you check others, when you check 20, for example, we say 20 plus 1 is 21. 4 in 21 is 5 minus 1 over 4. That could be also. When you check 25 plus 1, 26. And when you carry on, when you check 30 plus 1, 4 in 31. When you check other stuff, let's say 5 times 7, 35. For example, let's say 5 times 7, 35. 35 plus 1 is 36. So 4 equal to 36, so q over 9. So, but we can't use 9 modulo 5 because it's bigger than 5. So it's not only 4 modulo 5 that could be the result, 9 also could be the result, but it's not feasible because the modulo we are talking about should not be up to, the number we are talking about should not be up to the modulo or more than the modulo. So this is a perfect result. So the inverse of 4 is 4 modulo 5. So 4 times 4 is 16. Write that in modulo 5, you end up having 1 modulo 5. As simple as that. So we've come to the end of this very lesson. So in our next lesson, we're going to be looking at division. So during the division, we're going to be applying the knowledge of multiplicative inverse, while dividing. So if you gain one or two things from this very lesson, I would love you to subscribe to this very channel at EduMosaic and give me a follow, a Facebook and Revelation Hub, and share this lesson also with others. See you in the next lesson. Thanks and bye for now.